via a link later today. So it's 2 minutes after the hour. People are logging in. Hi, my name's Jim Saprinsky. I'm your host today. I am not going to belabor you with my video this morning, but we have an exciting topic today. It's a topic I wish we would talk about more. The capability of graph database within Oracle Database 26 AI. We have two distinguished folks joining us today. Melli Annamalai, Distinguished Product Manager for Spatial and Graph from Oracle, and Phani Chilakapati, who is the Global Data Architecture Leader from Industrial Scientific. We have a real world use case today. Could I have the next slide, please, Melli? And as I mentioned, my name's Jim Saprinsky. I'm your host today. We are doing this as part of the Analytics and Data Oracle User Community, or AnDOUC, or AnDOUC for short. We have an enormous amount of content, and it is dating back actually before 2020. We're going to turn the page on this a little later today and have our 2026 entry out there. But we have an enormous amount of content, and please feel free to come back and take a look at our TechCast archive. We have an exciting session coming up in the beginning of February as well on Oracle Analytic Cloud features, featuring five different speakers. And also, by the way, if you're interested in submitting a presentation, maybe you're new to presenting, maybe you're still learning how to present, this is a great way to practice, perhaps before a major event. Next slide, please. We also have innumerable places that you can go check us out. You'll see later today that the slide deck will be accessible, but also the entire recording will be out there on YouTube, on our YouTube channel. And we'll have a link to that later today, latest sometime tomorrow. But also be aware, we're out on LinkedIn. We have our own website. We're on Blue Sky. We're out on the Spatial and Graph Dig. And of course, we have our own Slack channel. If you want to join in and ask the experts at AnDOUC, you may join in, and the link is right there. One more slide, and then I'm going to turn this over to Melli. And of course, the big deal, the big cheese in the room. I don't know why I said that, but is our upcoming event in April, Analytics and Data Summit 2026. We have just published the initial agenda. We're actually still adding some sessions for the final day. And we're also doing something very interesting this year. You can see we have some younger folks that were in attendance last year. We're having a hackathon that is going to happen right after the event. We have some exciting speakers and topics. Go ahead and take a look at that link if you get some time. Save the date. And by the way, early bird pricing is open and will be open through January 31st. Please take a look at this. It's an outstanding session. It's in Redwood Shores, California. It is an excellent event. And with that, I'm going to hand this over to our presenters. Melli, Phani, over to you.
Thank you very much, Jim. Thank you always to the A&D for hosting us and hosting lots of interesting sessions. Today, I'm very excited to be here presenting with Phani, who has a very interesting use case, as Jim said. You might have heard me talk about graphs in the context of financial services, detecting anomalies, finding patterns, or supply chain analysis, and so on. Phani has taken graphs and applied it to an entirely different problem where you might not think graphs will be relevant, but Phani will show how relevant graphs have been for their use case. So again, I'm Melli. I've been with Oracle for a number of years, working on different technologies in the database organization, currently focused on graph databases and graph analytics. And Phani, would you like to introduce yourself?
Sure, yeah. First off, thank you everybody for joining. I know you guys are joining from different parts of the world. If it's not too late, then wish you all a happy new year. I hope it's going well for you already. It is for me because I'm part of this new community now. So thank you, Melli, for introducing me to the community. Thank you, Jim, for all the help with getting us set up here today. First off, my name is Phani Chilakapati. I work for Industrial Scientific. I'll talk a little bit more about the company itself, and then we'll dive deep into why graphs and how it has helped us and all the work that we've done with Oracle. But in the way of introduction, I deal with everything data at Industrial Scientific, and I'm looking forward to that session today. Hopefully, we'll generate some interest and also see how we can apply graphs on broader use cases. Thank you.
Thank you, Phani. So I don't want to assume that everyone on the call knows about graphs. I'll just take a few minutes just to go over what a graph is and why graphs are relevant for solving particular types of problems. And I'll go over this quickly because I did look at the participants' names, and I think several people are, at least some people I know, and they're familiar with graphs, I think. So the easiest way to think of a graph is to think of a social media example, something like LinkedIn. Like when you connect with someone from LinkedIn, it'll tell you that you have either you're already connected or you're connected through 2 hubs or 3 hubs. So if Ethan and Amelia are at an event like this and they want to connect with someone, LinkedIn will tell you it's doing some kind of graph analysis to identify how you go from Ethan to Amelia. And you can do other interesting things such as how many hubs exactly, and then identify which are the important entities. For instance, Alex and Amelia are kind of central to their communities. They're connected to a lot of people. And then also you can notice that the node Henry is connecting these 2 communities. Like if Henry were to decide that he didn't want to be part of these communities, then these 2 communities would be disjoined, they'd be disconnected. So a graph is all about entities and how they are connected. So that's the graph data model. Like we're very used to thinking of data in terms of rows and columns. Now it's the same data, but you think of it differently. You think of it as entities. Like in the LinkedIn example, it would be people and then connected to other people depending on whether or not they know each other. So the graph data model has these entities represented by nodes, also known as vertices. And then you also have the connections between them known as edges or relationships. So what's a connection? So I just said that you can have tables and you can represent the same data as a graph. So let's look at a very simple example here. I have a table with 4 rows, and I have another table which talks about how this information is connected, like row 1 is connected to row 4 is connected to row 3, and so on, something like this. When I take that same data and represent it as a graph, some things become more intuitively obvious that kind of 4 is kind of central. Here, 1 is connected to 4, 4 is connected to 3. The same information is in these tables, but it's kind of not, the way you look at tables and the way you query tables is not immediately obvious, whereas kind of this representation of the data makes it immediately obvious. And then we can see here that 2 is not connected to anything else. As Phani will show in his presentation, it's in his example, it is useful to find what things are connected to what things. It's also useful to find out where a connection did not exist, because that meant something. That meant that maybe an invoice was not billed correctly, if there was no connection between a customer and an invoice, for example. So here in this case, a visual representation of the graph kind of highlights that very simply. And we want to be able to run queries and so on to also be able to do that in the same intuitive manner. So there are many use cases that are relevant when it comes to modeling your data as a graph. Data is increasingly having more and more complex relationships. And again, in the social media example, you want to say, find me all people within 2 degrees of separation, 3 degrees of separation, or these are 2 entities, what's the shortest path between these 2 entities, and so on. These kinds of queries, when you try to think of a data in only a stable structure, it becomes, the queries can get very complex very fast. And the financial services industry, very interested in finding out things like, is money moving around in a cycle, which would represent a fraud ring, or evading some kind of taxes and so on, recommendation networks. Manufacturing, where you have components dependent on subcomponents, dependent on their subcomponents and so on. And all of this, you want to be able to query all of this at high speed. I was just talking to a customer this morning. They're looking at all of their devices and network resources, and they want to be able to, a user to ask a question and get back an answer in milliseconds. So let's just look at another example why graphs are kind of intuitive to solve some kinds of problems. So let's look at bank accounts and money transfers between bank accounts. So here, let's say Alex is transferring $10 to Rita, and that would be the graph representation of this. So typically, these kind of transactions would be represented in tables. So you would have, again, the bank accounts table, and then you have this table capturing information that an account has transferred money to another account. So you see here that account 1 has transferred money to 672, and so on, and account 672 is transferring money to 831, and so on. So if you want to say, has account 1 transferred money to 833, you have to kind of navigate all of these different rows, which, as I was saying earlier, is very intuitive when you think of it as a graph. And you can see here, compared to the simple example and the complex example, little more complex example, things can get complex very quickly. And even the graph also here has more entities and more relationships. So you want to do things like graph analytics or different types of graph queries to analyze this graph. Like, this is a simple query: which are the accounts that have directly transferred money to this account? And then you want to ask questions such as, which are the accounts that have indirectly transferred money to this account? Or I want to say, list all of the ways in which account 1 has transferred money to this account. So all of these different queries, if you were just using table structures, would get very complex. But we're able to write these queries more intuitively and get answers in a more intuitive way when you're using graph queries. So just think of your data in terms of entities and how they relate to each other. So you can say you want to follow the money or follow the relationships in social media, or follow other things, as Phani will explain in his when he talks about their use case. So we have these are just some examples in terms of, again, from banking, finding cyclical patterns, finding different paths. And here is an example from another customer. This is grouping, clustering accounts which have transferred money to each other. There are more connections between each other than across clusters. That's something a graph algorithm can help you do, and so on. So graph is a native feature of the Oracle AI database. We have had this support since 19C. We have added lots of new features in 26 AI. So you can natively build graphs from data you have in your Oracle AI database. And what you can do, you can create a graph from data you have in the database. You can query a graph, and what we have in 26 AI is the ability to write these queries in SQL. So you can see here the line in the middle here, the match clause, that's specifying the graph pattern. That's how you can easily specify the complex relationship that you're looking for. Now this is saying, find me all accounts that Russell has transferred money to in 1 to 3 hops. So this syntax gives you a succinct way of representing that query, and it is embedded within SQL. So you can use all the other SQL features that exist to add to your graph query. It's not a separate siloed thing. It's integrated with your database. You can just use it as part of your other operations. And of course, as the database adds more and more AI features, such as natural language processing, you can use natural language to write these graph queries as well. And the algorithms I was talking about, like clustering or machine learning algorithms or finding important nodes, we have a Python, a Java API for running these algorithms against your graph. And so the key advantage, one of the key advantages is, if you have your data already in an Oracle database, or you're anyway moving data into a Oracle database, then you don't need to move it again into a graph database. You can just create your graph within the Oracle database. This also enables very concurrent access and concurrent updates. So whenever your underlying tables are updated, your graph is instantly updated. There's no delay in terms of how the graph is updated, because the graph is just like a view on tables. It's like the JSON duality view, so you would instantly see any updates you have in the graph. So respect to tooling, lots of developers like to use VS Code today. So in the SQL Dev extension in VS Code, we have a graph visualization extension. You can run your graph queries and visualize the results right within that. We also have other tools that you can use from your browser or integrated into autonomous database. I just have one more example, and then I'll turn it over to Phani. And maybe I'll pause for questions, and then I'll turn it over to Phani. So this is an example for one of our hands-on labs where we have more tables than I had in the bank example, where you have, like, say, you have a customer ticket, a customer files a ticket on a product, the product belongs to a category, and the category has multiple categories. You can have a category having a subcategory and so on. And this is the type of thing that graph excels at, right? You have a hierarchy of categories the graphs can capture well. And then a product also has subcomponents. And the subcomponents, each subcomponent could come from a different supplier. So you have all of this integration, all of these connections. And then let's say you say that a customer has filed a ticket against a specific product. You can identify which category that ticket belongs to, and then you can look at the subcomponents. So you can look at not just the immediate category, but the other Uber categories that contain this category to understand which categories are potentially impacted. And then you have the product has components. Let's say there's 2 components. Each of them come from different suppliers. So you can basically connect a customer ticket to a supplier. Once again, you can do this with relational queries, but it becomes more intuitive to do this as a graph and ask more questions easily, such as which are the components that are having a lot of tickets filed against them, which are the suppliers who have no tickets, which means they're more maybe building better quality products, and so on. So I'll have one more slide where I'm just, this is something that when we worked with Phani, when we're building out this graph for them, is a screenshot from how quickly what they wanted to do with their data became complex. Like they're trying to navigate from the customer to the different orders, to the different invoices, different contracts, their addresses change, companies are acquired by other companies. So all of this, they had all of this data sitting in different databases, and they wanted a way to easily connect all of these pieces of information. And that is where I think graphs were helpful. So over to you, Phani.
Thank you, Melli. Did you want to take questions, or
Oh yeah,
switch
thank
over?
you. I should maybe take a few questions.
Yep, we do have a couple of questions here. They're quite good. Folks, if you have your hands up, by the way, just go ahead and drop your question in the Q&A. But we do have 2 questions right now, one from Hashemi. Are LLMs kind of blind about graph syntax? I don't think we're really talking much about large language models so far, but Melli, do you want to?
That's an excellent question. I wouldn't say they're blind. I mean, graph syntax is relatively new, so sometimes they are not. You need more prompting to be able to say, I want to use, I really want this graph syntax. I want the LLM to use this to provide me this graph syntax. So in Select AI, we have a feature now in limited availability for graphs, where we provide the prompting under the covers to get the right but it's not as robust as standard SQL queries yet, because there are not enough examples out there for the LLMs to be trained on. And I hope that answers the question.
Yeah, I hope so. Hashemi, if you want to ask more, go ahead. But I also have a question from Subir. He says, I'm frequently caught in a bind when deciding to go the ontology way to structure a new operating model with strict rules or axioms versus this approach of a graph-based view. Any suggestions on how to make that decision? I'll just stop there. The
That's a
question is a
good,
little bit more detailed.
that's a great question. And Jim, that's a good topic for a future webinar, I think. But let me try to answer this in like a few seconds.
Sure.
Which is, you're right that the property graph model, which is what we are focusing on today, gives you more flexibility that you don't really have to, you don't have the rigidity, as I think, to say that, I can only have these types of relationships between these two entities. I want to have the freedom to have different kinds of relationships, different kinds of nodes or vertices, and so on. Ontologies are useful when you want that, and I won't use the word rigidity, I'm going to use the word guidance. When you want that guidance about a particular scenario. So let's take a healthcare example. You are creating a graph in a healthcare setting used, for example, for use in an electronic health record or something. In healthcare, there are lots of pre-built ontologies which capture detailed knowledge about that domain. Let's say about how diseases are interrelated, or how diseases are interrelated with certain medications and so on. So sometimes you want that guidance because you don't want to be completely flexible. You want to be able to use that domain expert knowledge curated, that's domain specific, when you create your graph. At that time, ontologies become interesting, and there's a whole RDF graph model around that, which can effectively use ontologies. But in something like, I think, Phani's use case, where he's just wanting to connect entities in a flexible way, I think the property graph is a good fit.
We have a couple other questions, but I think they'll fit at the end after Phani presents. So let's move on, please. Over to you, Phani.
Sounds great. Yeah. Thank you, Melli. Can I grab the screen share?
Yeah, go ahead.
Okay. Just quickly confirm if you're able to see my screen.
We can see your screen.
There you go.
Yeah, perfect.
So it's okay.
Looks good.
All right. Well, again, first off, thank you everybody for joining and trying to understand what we've built here at Industrial Scientific. I think, Melli, you did a great job of introducing graphs and kind of talking about what kind of problems they solve today. And that kind of, took us to a different level of solving customer data integrity problem that we have at Industrial Scientific. And I'm pretty sure a lot of the folks who are attending this webinar today, they have similar problems, and they probably have different ways of solving it. But I'll give you an approach that we've taken with Graph today. Before we jump into this, let me talk a little bit about Industrial Scientific. We are a company that manufactures gas detection products, which are primarily responsible for making sure that people who go into work are exposed to good environment, clean environment, and they're not getting exposed to any harmful gases. Pretty much the vision of the company is to eliminate death on job by 2050. So in an effort to align with our initiatives and make sure that we are completely giving the right value from our from our products to our customers, one thing that's very important is to make sure that we have the right devices shipped out to the customers, which means that our customer data has to be intact. And in a business like what we've seen, we've expanded enormously in the last 3 years into Eastern Europe and Middle East, as well as APAC regions. So what happens is the customers' addresses are not very correctly coded, which means addresses could be anything like make a second right, when you hit a milepost, or go like 100 feet away, and then you'll find the address. Right? Those things will not help us ship our product. And we've seen some scenarios like that. So all in all, what happened is overall, the customer data itself was not very integral to what we see in our books. This led to an overarching problem, as in what is our customer data even correct today? right? And for us to identify how to solve this problem, the very first thing we had to do was size the problem. How much of our customer data is not right? But before we jump into that, I think the problem statement is pretty clear to us that since our customer information is not right, there's a lot of things that are happening internally with Industrial Scientific, which is, first of all, we are not able to figure out how much are we earning from any of these sales that we are making. And then how many reshipments are we doing because the products are not reaching to our customers? How much hit are we taking in terms of customer sentiment? And what is that leading to dropping any customers from our contracts? And then, of course, there's a huge hit on the operations side where we have to do a lot of rework in cleaning up the addresses, cleaning up our contracts, sending new orders to the customers repeatedly because they have not received the orders in the first place, all because, the customer information is not correct. And a lot of companies invest a lot of time into this, but since we've seen a lot of expansion, we wanted to do something very quick and something where we can show value and also size the problem and get a quick fix to it. And luckily, we are an Oracle shop. We have ADW as one of our data warehouses, and ADW has this feature of using graphs and also build applications through Apex. So we wanted to do something really quick to figure out how we can solve this problem. I hope I'm going at a decent pace, but if I'm too fast or too slow, do let me know. So let's talk about how we see our business at Industrial Scientific. We are a manufacturing company. We manufacture products, and then we ship them out to customers. And we are not directly selling products. Most of our products go through subscription bundles, which means that we have very elaborate contracts written out with customers. So if we segregate this diagram into two pieces, one is the metadata layer and one is the transactional layer. We want to make sure that the metadata layer is as strong as it can, right? We want to make sure that we only have one version of our customer. We only have that customer reflect in all the contracts that we have. For that customer, of course, and we want to make sure that the products that are associated with these customers are sitting in these contracts are the ones that are supposed to be at the customer. Otherwise, we'll be billing the wrong customer or we'll be billing the customer for the wrong product. And a shift in any of this data will lead to a trickle-down effect, right? The orders get mismatched. We have exceeded the number of transactions instead of what we're supposed to bill. Customers, the products will end up at different locations, and these devices are transmitting telemetry data back to us. So our transactional data gets muddled up as a result. And you can see that the customer success team has to work extra to answer all these questions. That as a result of the complexity that gets spread out so easily. So I talked about sizing the problem earlier. If a company of our size were to do this analysis, it would take at least 6 months to figure out, what amount of our customers are not correct. And let me just take one step back. The reason why any company has incorrect customer information is because they have multiple touch points for customers. So they have a CRM system where sales are recorded, customers are created. They have a back office system where all the customers are created again, either in a financial system or in an order management system. And there's a customer-facing application for most companies where customers actually see what they're paying for and the kind of devices that are installed on their sites. So there are 3 or 4 different places where customer information gets touched, and that can easily escalate to a customer information going bad. So a simple answer to this is have a good integration system. As easy as it sounds, it's not that easy to implement. So to figure out, what our gap was, we took a graph approach. We identified all the customers in all the 3 systems, and we found out that we have a 15% of error across the systems. But then 15% seems manageable. But what we were able to analyze is that 22% of our contracts were impacted by these 15% erroneous customers, and that led to about 3 times the number of orders that we had to place in terms of canceling the order, placing a reorder, and then shipping the orders. And then we had to provide credit memos and then create new invoices. And on top of that, we also had to give heavy discounts because we weren't able to satisfy the order the first time around. And it also took a hit on the inventory because we had to bring back the devices that we shipped and then send them new devices. Or sometimes we couldn't even figure out where the devices were because they were just lost in transaction. And then, as I was talking about how customer success takes a hit, we got more inquiries about these products saying, hey, where's my order? Or, my order is sitting at some other location. So when am I expecting my order? So what we did was we worked with Melli and her team. There's something called a Code Innovate where, Oracle works with our development team to understand how they can solve this problem for us. So now we'll jump into the architecture itself. I hope everybody understood the problem that we were trying to deal with. Let me know if you have any questions. Should I pause here or just move on?
Jim, there were a couple of questions. Are they on the problem itself, do you think?
No, I think they're more generic. Let's save those for the end.
Okay.
Yeah.
Okay. All right. Sounds good. Yeah, I can't see because I'm in full screen mode, so I'm not able to see the questions. I apologize if I'm being a little blind here. But so let's talk about the architecture, right? As you can see here on the very left side, we have our source data, which is an Oracle database. And for the sake of the experiments that we did initially, we stood up a 26 AI database. Back in the day, a couple of months earlier, it was 23 AI, but now it's 26 AI. So we've put in very curated and siloed data sets, which were in 3 different systems, into 26 AI using a very simple ODI, a DIS approach. And once we did that, instantly, we knew that the data was not matching up either because the customer name, for example, Marathon Oil, in our Oracle system will show up as Marathon Maritime in Salesforce, or it will say Marathon XYZ in our customer-facing portal. So what Graph did was we've done a proximity match, and we've identified that all these 3 accounts are nothing but the same. And the way we were able to connect them was either with addresses or with customer numbers. So there are 3 or 4 parameters which we used. So end of the day, we knew that Marathon Oil in our Oracle system was the same as Marathon Maritime and Marathon ABC in another system. And at that point on, we've understood how much business did we do with these 3 customers, and how much of it is actually reflecting in our financials, and we were able to identify that gap. Now, identifying the gap is one thing, but how do we take it to the business? Because as a technical team, I understand, what the records mean. When I look at it, there are like 30 different records in each system which don't match with each other. But how do we fix that problem, right? So Oracle 26 Autonomous Database has this very good add-on, which is called Apex, where you can actually build your own application. You're not just querying data from a database and you're showing records that probably don't mean anything to the business users. So we've built this Apex application where anytime a customer or a customer service representative puts in the name of the company, it shows the difference in the accounts, either be it the name or the customer number or the address or the devices that were shipped. It pretty much shows all the differences visually. And once we do that, then the CSRM will be able to make a call whether to clean up that data or whether to keep it the same, or call for different types of actions. And we've used Oracle Integrated Cloud Integration Cloud, which is also an OIC service. And then we've pushed that data up to Salesforce. At this point on, I think the customer service representatives are able to take action and figure out what has to be done with these customers. Once the data is corrected, it just goes and updates itself into the source data system. So here we've created a very simple enrichment loop. And I think a lot of data governance platforms do this, but to set up these rules, you have to work with somebody who's a technical resource, have the business requirements translated into something more technical, which probably doesn't make sense by the time it gets resolved and then goes back into the system. So one good thing is we were able to work with the business very closely on this because they understood the technology is very simple and it's kind of low code once you start building applications in Apex. So that way, I think we took full advantage of it. And if you ask me how long it took, I think it took less than 2 weeks for us to do all this. 1 week, we've spent enough time with the Oracle team, and we had a good amount of pre-work before that, which is so we spent another week getting these data sources from all the three systems. So here's our money slide. I know Melli, you talked about money in a different way. You were talking about transactions and money transferring, but this is about what it costed us at Industrial Scientific, or what would it cost other companies. So we are a fairly small company, so we don't have the liberty of implementing large-scale enterprise applications in terms of metadata management or data governance. I've drawn these numbers from my previous experience at bigger organizations like Nestle and Fannie Mae, where we implemented tools like Collibra, Alation, or even Informatica Data Catalog. They were huge systems. We had huge resources. The problems were also bigger. The kind of impact that we were looking for is in the millions of dollars. So we were able to actually spend any number that you see here. But with a company as small as Industrial Scientific, I wouldn't say it's a small company, but it's compared to the other companies, it's fairly small. So we don't have the leverage of spending this kind of money. So I would say after we implemented the solution, we've started tracking what's the total cost for ownership for the solution that we've built, and it's probably less than 5%. It's actually lesser than that, but it's somewhere in that ballpark. But let me go back to this slide. So these are all data governance tools. So it takes a lot for any organization to strategize and implement these tools, and have the manpower and the KPIs associated to figure out are we really getting value from this. But when we implemented Graph, we've started seeing value since week 3, and we've had the solution for about 4 weeks. And I can what I'm reporting as of today is that we have about 2% error in our customer transactions, because the enrichment loop has been working very well for us. And we've achieved a couple of things. One is we have actionable items around data governance. We are able to create our own workflows based on the business logic that works for us, because I think having a deep-seated business understanding of what these workflows are is very essential to having a very tight governed data quality. And we were able to discover the problem, and not just this, but now we have a very creative way of identifying where the patterns don't align. And this kind of discovery, I think I have not seen with any other platforms. And we are also able to build this lineage of how is this data traversing from 3 different systems, and then how is it getting into our reporting system, and then how is it getting reported out into our revenue systems. So I think the benefits of implementing Graph, I've seen them very clearly in the last couple of months, and I'm a strong advocate for why we should use Graphs if we have a problem, and if we are trying to do some deep-seated analysis of are there any process failures, or are there any bottlenecks? How do we discover them? How do we rectify them? I believe that this is a very data-driven approach, and Graph can help anybody who has a similar problem. So with the success of that program, we've also put another lens for Graph at Industrial Scientific. We are in the process of acquiring another company based out of a completely different region. But what happens is now, with the acquisition of companies, we are dealing with two sets of resources, 2 sets of accounts, 2 sets of billing information. Now, how do we merge them? And how do we get a unified view? And I think Graph is an excellent use case, and we've actually started to put an architecture together for this. It's a little too soon to discuss that, but maybe in another session. But end of the day, once we run Graph on these 2 entities, we'll start finding similarities in what are the sales territories, how can we bring in the sales commissions, and how can we merge the sales commissions, so one set of people don't feel like they're compensated less versus the others who think that they're compensated more. And then we can also start looking at product mixes and see which products are more profitable, which products are less profitable, which products are self-competing in terms of the offerings that both these companies have eventually when they merge. And we can also do some profitability and margin analysis, and also position ourselves in a way that we are not at an imminent risk of churn once these two systems integrate. So I believe that there's a lot of potential with graphs. There are a lot of simple use cases that we can build, and earlier, before I implemented graphs, I knew that this was a complex architecture, or maybe people don't understand graphs. But after implementing it, I felt like it's pretty simple. All we have to do is understand the data sets that we're working with. And I think there's a lot of potential, and I can vouch for using graphs for a ton of other use cases. So that brings me to the end of my presentation.
Let me grab the share from. Go ahead, Jim. Oh,
Yeah.
maybe you should do questions now.
Yes, let's take a look at some questions. Sorry, Phani, I hope I didn't cut you off.
No, you're fine. I just rambled for like 20 minutes, but let's see.
No, that was fantastic. So there's a lot of really good feedback here. Subir, thanks for questions. Valentin had a question. Can we share some examples of how to build a knowledge graph in Oracle AI database to be used for GraphRag? And Melli, I see that you answered that question in the Q&A. There are some excellent live labs out there already. I think I also posted in here the point that Melli's already done a blog post from, I think, November 20th in 2025 that really gets into what's called GraphRag. And that's it's close to this, but it's a little bit more specialized. Melli, do you want to speak to that a little bit?
Right. So GraphRag, knowledge graphs, let me start knowledge graphs. So knowledge graphs is, of course, a very interesting topic in the era of AI. And I think primarily because graphs are useful in capturing complex information in an intuitive way. Like earlier, I was giving the example of healthcare and how diseases interact with each other. Graphs kind of for a good data model for capturing that information. So folks want to use knowledge graphs to kind of, in some cases, guide an LLM or to tell an LLM, this is the information that we have, like prompt an LLM saying, I want to use the information that's structured in this way, and I want you to answer my question using elements from this knowledge graph. So there are this, so I think of knowledge graphs as a special kind of graph that works with real world concepts and relationships between them, as opposed to, let's say, in Phani's case, this was actually their customers, their orders and their invoices, which is kind of, it's a bit specific to the data elements in their organization. Whereas a knowledge graph would be more like, okay, the flu is connected to being exposed to another person with the flu, or is connected to this particular virus in this year. I mean, more kind of real world concepts. So, and how do you create knowledge graphs? Some of them are pre-built, like ontologies. They are expert curated domain-specific knowledge graphs. Or now there's increasing interest in creating a knowledge graph from documents. So, and we can do that today by sending a document to an LLM and say, okay, create this graph for us, identify the entities and relationships, and we can then store and manage and query the graph in Oracle database, which is what those live labs do. And more native integration is on the roadmap.
Great. This question, Subir had quite a few interesting questions. Funny, the question that Subir had was the rules that you're talking about. Is there a standard framework for managing rules? Any suggestions for an industry-based framework that folks can align with before you get to the technology-based rules implementations? And Subir also noted there's overwhelming complexity of rules, and businesses have challenges often to address and govern those rules. Perhaps you could speak to some of the challenges you might have gone through while you were implementing your solution.
Great. Yeah. Thanks for that question, Subir. First of all, we wanted to stay away from rules because that's what will get us into trouble, right? That's exactly where we failed when we implemented these complicated data governance programs. Is the rules are so complex and people get lost in what's right and what's wrong. But we wanted to tackle the problem first of all because we knew the customer data was not right. So our only rule was how do we get a unified view of the customer, right? We took one step at a time, and we got to a point where now we have a process to address bad customer data. And the rules were pretty simple. Do we have the invoice information for every customer? Do we have the product lineup for all the customers? How many cases did we receive from them? How many complaints did we receive from them? And then everybody agreed that these are the factors that they wanted to quantify the problem around. And that was the only thing. But once we figured out how to fix the customer information, there were about 10 different rules that came out, based on customer types, based on, invoice types. And that was part of, coming up with our own workflow. And I think to embed these kind of rules into a generic framework, I can give you some high level guidance, but I think every business works in its own way. So, I'm happy to talk to you at a later point about it and, give you at least my approach of, how we've solved it. So basically we have two lenses. One is a customer lens and one is a product lens, because those two are the major, contributing factors to our metadata.
Follow on to that. Not sure we're going to be able to answer this in 12 minutes here, but Salim asked, I'm looking into an agentic AI solution for design and engineering coordination. Salim, I think I've got that right. Do you foresee this going forward, Phani, as eventually implementing some sort of agentic AI solution around what you have, or do you think your company's at that phase yet? And Melli, your ideas on that as well, because we hear this a lot, right? Everybody wants to do agentic AI, right? So, where do you see the capabilities for graph database, especially?
That's a really good question. Do you want me to go first, Melli?
Yes, please.
Okay. So the beauty of 26AI is it's a vector database, right? It did not exist when we started with 19C. Right now, it's completely vectorized. So you can write your, RAG statements, use natural language. First of all, I think that itself is a big push. So we're not just writing queries, match queries, but you can pretty much look at the lat long of all these customer information and figure out, any white spacing. For example, if you want to figure out, how many competitors exist in a certain area, you can pretty much do that using, the vectorization of certain columns that you need in 26AI. And I'm also in conversation with the Oracle team on the new AI data platform that's coming up, where we use the 26AI data and then figure out how to put an agent on top of any of these corrections that are supposed to be made. We wouldn't want CSRMs to spend a lot of time figuring out what is the right address or how do we correct this address. We'd rather train the agents and have them self-insert corrected information into Salesforce. So we will probably put a human in the loop at a point where they will have to verify and approve the change. But up until then, everything that's happening in the enrichment loop right now, we would want to automate it through an agent. And that itself saves a lot of time for us.
Yeah, I have nothing more to add except to say that there are new, like Phani said, vector feature is now integrated into the database. Agentic AI APIs are being added. So we'll be able to leverage anything that is in the database very easily, along with the graphs, because they're all part of the same database.
Right. And just to chime in a little bit on that, Melli, I recently did kind of a deep dive into this too, just to try to figure out not the document side of it, right, the unstructured data, but the structured data. And one of the things I found out about graph, right, that if you're, we talk about property graphs versus RDF graph, which is a totally different ball of wax, right? But you can, with relative ease, transform data into RDF relationships, right? RDF graphs as well. And it's relatively simple to do. So
That's a good
it's,
point. Yes.
yeah, so it's not just, we have this idea of the graph table, right, with operational
Yeah.
property graphs for high speed type, operational type of analyses, but you can also kind of do the step back type of analysis, very similar to what Phani and his team has done. So
Yeah.
fascinating topic. Obviously, graph is coming to the forefront. We have no other questions open at this point, but there's some great resources here, and we're going to add all this into the slide deck that we're going to put together for this. If I could have our concluding slides, we're going to wrap up here. I don't see any other questions at this point. So yes, I just wanted to mention, several folks said, where are the slides? I want to see the slides. Well, later today, you'll see a new tab out here for 2026. There'll be the title for Connecting the Dots, and also of the video replay will be right here. It's actually going to take you right over to our YouTube channel, and you'll be able to see that information, and the slides will also be available right there in PDF format. So again, if you're interested in perusing this stuff, we've had some fantastic slide sessions, I should say, TechCasts in the last year, as you can see, stuff ranging from Oracle Analytics Cloud through spatial and graph. We had two really fantastic spatial and graph presentations in the past few months, and some really cool things that are out there. We're trying to stay on the cutting edge. One more slide, please. I think maybe only one more slide. Yes, I believe this is my final slide for the day. Again, we want to tell you all about this conference that's coming up April 14th through the 16th in Redwood Shores, California. Yes, at what we used to call Oracle headquarters, which we now call the original headquarters. And if you haven't taken a look at the agenda, we mentioned it's just been published as of, I believe, this Monday. Take a look at this conference. It is an amazing conference. It is one of the few that really does focus in on spatial and graph, of course, graph database as part of that, as well as Oracle Analytics, FDI, Oracle apps based on analytics, spatial and graph, as I mentioned, and of course, all the flavors of AI, agentic, generative, RAG, and all the stuff inside the database. So we have some fantastic sessions out there already. Like I said, we're going to add probably a few more for the last day, but the agenda is almost finalized. And by the way, the food's great too. Not that necessarily matters, but they feed us very well. We'll just say that. Some of the best conference food I've had. So anyway, I just wanted to mention that as our closing slide. We really have a couple of interesting final questions. What would be a good way to get introduced to graphs and playing with 26AI using graphs? Melli, I think you've already answered those with the couple of live labs that you put in our posts.
Right. And I think if you go into, live labs and search for graph, you get a whole bunch of good labs. Yes.
Yes. Excellent. Yeah. So a last couple second questions, but thank you for presenting today, Melli and Phani. Wow. A really interesting look into graph database. And thank you all for attending today. Stay tuned. We have even more excellent sessions coming your way.
Thanks a lot.
Thank you, Jim. Yeah.
You're very welcome. Have a great day.
Thank you. Bye-bye.
Bye.